Welcome to this custom deep dive. We are so incredibly glad you decided to join us today.
Absolutely. It's great to be here.
If you're a regular listener, you know we normally take a big stack of research and notes and sources, and we distill it all down into the most, fascinating, mind-expanding takeaways.
Right. The really good stuff.
Exactly. But today, we have a very special mission, and it's tailored specifically for you. We are putting you straight into the captain's seat of an Airbus A320.
Which is just a brilliant aircraft to talk about.
It really is. On the desk between us today are excerpts from the official Airbus operational philosophy and flight deck design principles.
The actual literal playbook.
The playbook, yeah. And our goal for this deep dive is to completely decode the psychology, the human-machine interface, and the underlying philosophy that governs exactly how A320 pilots interact with what is essentially a multi-million-dollar flying computer.
It's an incredibly rich topic. And looking at this virtual set we've switched to today,
Oh, yeah. Do you like it?
I love it. The high-tech aviation layout, the flight telemetry charts glowing in the background, it perfectly sets the mood. When we analyze the A320, we are fundamentally examining an environment where cutting-edge engineering just collides with human psychology.
Yeah.
It is a masterclass in how humans and machines are supposed to communicate.
Because flying a modern Airbus A320 isn't just about, pulling levers and pushing rudders anymore. It is about a highly specific, carefully orchestrated relationship.
A partnership, right?
Right. It's about trust, communication, and deeply ingrained design philosophies. Okay, let's unpack this. There is a huge misconception out there, especially among the flying public, that modern planes basically fly themselves.
Oh, you hear that all the time.
All the time. People tend to think an A320 pilot just pushes a button in New York, reads a newspaper, and wakes up in London.
Which couldn't be further from the truth.
Exactly. Looking at the very first design requirement in the Airbus philosophy, that idea gets completely shattered.
It does. And it does so unequivocally. The very first of their 10 high-level design requirements states that the flight crew is ultimately responsible for the safe operation of the aircraft. Full stop.
Not the computer.
Not the computer. Despite all the advanced fly-by-wire technology and the millions of lines of code running in the background, the human beings in those seats bear the ultimate responsibility. The aircraft is a tool.
A very expensive tool.
A highly advanced, very expensive tool, but still just a tool in the hands of the crew.
Which brings us to how Airbus actually views all that fancy technology. If the human is ultimately responsible, what is the computer's actual job title?
What's fascinating here is how Airbus explicitly defines automation. In their design philosophy, automation is strictly considered an additional feature.
Just an add-on.
Exactly. It is not the core aviator. It is an assistant. It is entirely up to the flight crew to decide the appropriate level of delegation and assistance they need at any given moment. Think of the pilot as a manager of resources. The automation is instantly one of those resources available to be deployed.
So the computer is the smartest co-pilot you could ask for, but you're still the boss.
Always the boss.
And to make sure the boss can do their job effectively, Airbus built these flight decks to accommodate an incredibly wide range of pilot skill levels. They explicitly factor in human strengths, but more importantly, human weaknesses.
Right, to mitigate potential errors.
Yeah, to stop us from making mistakes. The whole layout of the A320 cockpit is actively structured to facilitate and enhance crew communication, task sharing, and teamwork.
But there's a catch to that.
Yeah.
You'd think that accommodating human weakness means Airbus just throws every single new automated gadget into the flight deck to save us from ourselves.
Like more screens, more alarms.
Yeah, but they don't.
Yeah.
According to their core principles, new technology is only brought into the flight deck if it offers a significant safety benefit, an obvious operational advantage, and responds clearly to a need the flight crew actually has.
It can't just be a gimmick.
No gimmicks allowed. A new piece of tech has to literally earn its keep on the panel.
I see that reflected in the strict hierarchy of priorities programmed right into the aircraft's design. The A320 operates on 3 core priorities, and they are ranked in a specific, unbreakable order.
Unbreakable.
Number 1 is safety. Number 2 is passenger comfort. Number 3 is efficiency.
And that strict order tells you everything you need to know about the engineering mindset. Think about a scenario where an A320 encounters severe turbulence.
Which happens fairly often.
Exactly. The aircraft systems and the crew's procedures will immediately sacrifice efficiency. They might burn more fuel to climb to a different altitude, or they might slow down just to ensure passenger comfort.
Makes sense.
But they will absolutely sacrifice both comfort and efficiency if it means maintaining the ultimate safety of the airframe. It's a formalized decision-making matrix built into the DNA of the plane.
I want you, the listener, to think about this for a second. Think about the software or the digital tools you use every day at your job. Are they actually designed to assist you, or do they constantly try to take over?
Usually the latter.
Right. Do they respect your ultimate authority, or do they lock you out when they think they know better? Airbus firmly chooses the former. They give the crew full authority via intuitive actions to eliminate the risk of over-controlling the aircraft.
It's a profound statement on human-centric design. We build machines to serve our purposes, but in high-stakes environments, we sometimes lose sight of that and let the machine dictate the terms.
Yeah, we just follow the GPS into a lake.
Exactly. The Airbus philosophy ensures the human remains at the center of the operational loop.
So if the human is at the center of the loop, managing this massive flying supercomputer, how does the machine actually communicate with the pilot without completely overwhelming them? I was looking at the diagrams for the A320 overhead panels.
Oh, those are fascinating.
They are, and I expected it to look like a chaotic 1980s spaceship with hundreds of blinking lights. But it's actually incredibly streamlined.
Well, if you look at older generation aircraft from the 60s and 70s, the cockpits often did look like a Christmas tree.
Just lights everywhere.
Hundreds of dials, analog gauges, constantly illuminated switches, all demanding the pilot's attention simultaneously. It was a massive cognitive load.
Just a wall of information.
Airbus revolutionized this with what they call the dark cockpit concept, specifically for the overhead panel where most of the system controls like hydraulics, electrical, and fuel live.
The dark cockpit concept. It is such a brilliant user experience design choice. The rule is incredibly simple. If no lights are illuminated on the overhead panel, it means everything is in a normal state.
No news is good news.
No news is good news.
It's elegant in its simplicity. If a system is operating normally, it stays dark. You only see a light if a system is turned off manually, if there's a fault, or if it requires your immediate attention.
Which makes troubleshooting so much faster.
Oh, incredibly fast. By simply glancing upward, an A320 pilot can instantly assess the health of the aircraft's systems. If the panel is dark, you're good to go. It drastically reduces visual noise.
And when you do actually need information, Airbus employs the need-to-see concept.
Right. The need-to-see concept ensures that pilots are provided with uncluttered, relevant, and redundant safety data. The screens in front of the pilots don't just vomit every possible metric at them at all times.
Because you don't need to know the exact hydraulic pressure if it's fine.
Exactly. They filter the data. They give the crew exactly what they need, exactly when they need it, depending on the phase of flight, without overloading them.
It's like having a hyper-competent assistant who only hands you the exact single page you need for a meeting, rather than dumping the entire filing cabinet on your desk and telling you to find it yourself.
That is a perfect analogy.
And speaking of filing cabinets, the design philosophy heavily pushes a less paper cockpit to improve information access.
A huge part of that is the ECAM, the Electronic Centralized Aircraft Monitor. It's essentially a smart screen system sitting right in the middle of the dashboard.
Right between the pilots.
Exactly. In older planes, if an engine ran hot, a pilot would have to dig through a massive physical paper manual to find the exact troubleshooting checklist.
While flying the plane.
While flying. In the A320, the ECAM automatically detects the fault, pops up the exact relevant data on the screen, and provides the step-by-step checklist to handle it right there.
The physical arrangement of all these panels and screens is optimized specifically to reduce workload and minimize what they call head-down time.
That head-down time is a critical metric in aviation. You want the pilot's eyes up, looking outside the window, monitoring the primary flight displays, and maintaining situational awareness.
Not staring at their knees.
Right. You do not want them burying their heads in the center console, hunting for a switch, or reading a binder if it can be avoided.
So why is this level of sensory management, keeping the lights dark, filtering the screens, minimizing head-down time, why is that so absolutely crucial for an A320 pilot?
Because in a crisis, cognitive load is a pilot's absolute worst enemy. When an emergency strikes, a psychological phenomenon called cognitive tunneling occurs.
Cognitive tunneling.
Yes, the human brain's capacity to process peripheral information narrows significantly due to stress and adrenaline. If a pilot is overwhelmed by a barrage of non-essential alarms, a wall of flashing lights, and cluttered screens, they can easily miss the single critical piece of information they actually need to save the aircraft.
Wow.
These design choices are explicitly about preserving the pilot's mental bandwidth so they have the cognitive space to solve the actual problem.
Preserve the mental bandwidth. That is such a crucial takeaway. Okay, here's where it gets really interesting. Let's move from the visual information on the screens to the actual physical controls the pilots touch.
The hardware?
The hardware. The A320 is famous for replacing the traditional bulky control yoke, that big steering wheel right in front of the pilot, with a side-mounted stick. The Sidestick.
The Sidestick fundamentally changed the geometry of the modern cockpit. Because it's mounted to the side console, it provides the pilot with a completely unobstructed view of those main instrument panels we just talked about.
You can actually see the screens.
You aren't peering over or around a moving column to read your airspeed or your attitude. And for anyone not familiar, attitude just means the angle of the plane, whether the nose is pointing up or down or rolling left or right relative to the horizon.
Right. But the design goes way deeper than just visibility, because the relationship between the pilot moving that side stick and the aircraft actually responding is governed by specific digital control laws.
It's a fly-by-wire system.
Exactly, meaning there are no physical cables connecting the stick to the wings. It's all electronic. And crucially, when the A320's autopilot is engaged, that side stick is physically locked in a neutral position.
That is a vital safety feature to prevent simultaneous pilot and autopilot inputs. In older aircraft, if the autopilot was flying, the yoke would physically move in front of you like a ghost was driving.
Which is so creepy to watch.
It is. But if a pilot panicked and grabbed it, they could end up fighting the autopilot, which can literally tear an aircraft apart. By locking the side stick in neutral when the automation is flying, Airbus ensures there is zero ambiguity about who is manipulating the controls.
It's either you or the computer.
Exactly. If you want to fly manually, you click a button to disconnect the autopilot, and the stick is instantly yours.
But wait, if the stick is on the side and the captain and the first officer both have one, what happens if they both try to fly at the same time? In an older plane, the yokes are mechanically linked together. If one pilot pulls back, the other pilot's yoke moves back too. You can feel what the other person is doing.
That's a great point. Because the A320 side sticks are not mechanically linked, you don't feel the other pilot's inputs.
Right.
If both pilots try to move their sticks in different directions at the same time, the computer averages out their inputs, and the aircraft immediately blares an audio warning shouting, "DUL input, DUL input," to alert them.
So it literally yells at you.
It yells at you. One pilot has to press a priority takeover button on their stick to lock the other pilot out. It forces clear verbal communication about who has the controls.
And when you do take that stick and take control, you are protected by the A320's flight control protections. This is where the machine truly acts as a guardian.
These flight control protections are designed to give full authority to the flight crew so they can instinctively achieve the best possible aircraft performance, while simultaneously minimizing the possibility of overstressing or damaging the aircraft in a severe emergency situation.
Okay, so if I'm a pilot and I panic, say another plane suddenly appears in my flight path out of the clouds and I just yank that side stick as hard as humanly possible, what actually happens? Do I flip the plane?
In an older conventional plane, you might overstress the airframe, snap the wings, or throw the plane into an unrecoverable stall.
Yikes.
But in the A320, the fly-by-wire computer basically says, "I understand you need to move aggressively, but I won't let you break the wings."
That is amazing.
If you pull the stick all the way back to the absolute physical stop, the computers will give you the absolute maximum safe performance the wings can generate, but it stops you right at the aerodynamic limit. It protects the aircraft from human panic, while still giving the human maximum evasive capability.
It's an incredible safety net. Now, I want to explore one of the most counterintuitive features for pilots transitioning to the A320 from older aircraft, the non-back-driven thrust levers.
Oh, this was a huge controversy when it first came out.
Really? Because in older planes, when the autothrottle adjusts the engine power to maintain speed, the physical levers between the pilots actually move forward and backward on their own. It's a very tactile visual cue. But Airbus completely ditched that.
They did?
The A320 uses a non-back-driven concept. The levers just click into a specific physical notch, a descent, and they stay put.
If we connect this to the bigger picture, it represents a massive fundamental shift in how humans are expected to monitor machine performance. Airbus decided that tactile feedback from a moving lever was an outdated way to manage modern jet engines. You don't feel the engine schooling up, increasing their RPMs through your hand anymore. Instead, the crew monitors the aircraft's energy state via the highly accurate speed and engine parameters displayed on the screens.
It completely changes the habit loop. Instead of keeping a hand on moving throttles to feel what the plane is doing, you have to actively monitor the digital readouts.
It reinforces the need to see concepts we discussed earlier. The digital data on the screen is infinitely more precise than the physical position of a lever anyway. It forces the pilot to be a sophisticated systems manager, reading the actual data, rather than relying on a generalized physical sensation.
So we have this beautifully designed, highly protected, dark cockpit with digital throttles and side sticks. But how do the pilots actually operate within it day to day? What is the rule book?
Because you definitely need one.
Right. The Airbus procedures are heavily categorized to organize task sharing and guide pilot interactions.
They break it down very logically. First, you have routine procedures. These are your standard operating procedures. They are designed chronologically by the phase of flight, pre-flight, taxi, takeoff, cruise, descent.
The standard stuff?
Right. Think about routine procedures like your morning commute. You don't need a checklist to put your car in drive, check your mirrors, and hit the gas. You do it from memory. Airbus relies on that deeply ingrained muscle memory for standard flying.
But the moment something weird happens, you have the non-routine procedures, which is a whole different ballgame.
The moment an engine light comes on or its system fails, they completely switch gears.
Yeah.
You aren't allowed to rely on memory anymore.
Really?
Yes. You have supplementary procedures, which are performed using a strict read and do principle. You literally read the step out loud, and then you do the step.
Just to make absolutely sure.
Exactly. For complex troubleshooting, the crew relies on those guided procedures presented directly on the ECAM screens or in the Quick Reference Handbook. The only exception is for severe time-critical emergencies, which do require immediate memory items before you grab the book.
So what does this all mean? We have the dark cockpit, the fly-by-wire protections, the non-moving thrust levers, and all these procedural categories. How does a human being actually synthesize all of this in real time at 35,000 feet without getting overwhelmed?
It all comes down to the core philosophy.
Right. To tie it all together, Airbus promotes 4 absolute golden rules for pilots. These rules apply to all normal and all abnormal operations. If you are an A320 pilot, these 4 rules are your religion.
They truly are the bedrock of the Airbus operational philosophy. Golden rule number 1, fly, navigate, communicate.
Fly, navigate, communicate, and the source material is explicitly clear. These must be performed strictly in this order with appropriate task sharing.
It sounds so incredibly simple, but in a terrifying emergency, human instinct often gets it entirely backward.
How so?
Well, when a loud alarm goes off, the human brain panics and wants to offload the problem. Pilots might instinctively grab the radio to start talking to air traffic control to explain a problem or ask for help before they've actually secured the flight path.
Oh, wow, yeah, I could see that.
Rule 1 says, suppress that urge. Fly the plane first. Keep it in the air. Keep it safe. Figure out where you are second. Talk to ATC last. If you drop the first ball, nothing else matters.
Aviate, navigate, communicate. It's a life-saving mantra that fights against our natural panic response. Golden rule number 2. Use the appropriate level of automation at all times.
This goes back to our very first point about automation being an assistant. The flight crew must continuously evaluate if the automation is actually helping or hindering the current situation.
Right.
And the rule explicitly notes that the appropriate level of automation absolutely includes manual flight. If the computer is doing something you don't understand or doing something you didn't ask for, turn it off. Fly the plane yourself. You have to understand the operational effect of whatever system you have engaged.
Which feeds right into golden rule number 3. Understand the FMA at all times.
Yes, the FMA.
The FMA is the flight mode enunciator. It's the text readout at the very top of the primary flight display that tells you exactly what the computers are currently trying to do.
Pilots must monitor, announce, confirm, and fundamentally understand the FMA. It is the primary way the aircraft communicates its intentions to the crew.
It's the plane talking to you.
Exactly. If the pilot thinks the plane is descending to a specific altitude, but the FMA says it's doing something else, you have a very dangerous disconnect. You have to know what guidance modes and targets are currently active.
And if there is a disconnect between what the pilot wants and what the FMA says, that triggers the final rule. Golden rule number 4, take action if things do not go as expected.
This is the ultimate failsafe built into the philosophy. If the aircraft deviates from the desired path, or if it isn't hitting the selected targets, The pilot flying must take action.
Don't just watch it happen.
You don't sit there staring at the screens, waiting for the computer to figure it out or fix itself. You either change the level of automation to fix the issue, or you immediately revert to manual flying.
You take control. You are ultimately responsible.
This raises an important question. Think about how this translates outside the cockpit. How often do you, as a listener, revert to manual when the automated systems in your own life start behaving unexpectedly?
That is a great point.
Whether it's a GPS giving you strange directions into a lake or a software tool at work going rogue, do you blindly trust the machine because it's a computer, or do you step in and take manual control?
The trust we place in machines has to be conditional. As we wrap up this deep dive, it's clear that being an A320 pilot is about so much more than just technical flying skill.
Much more.
It is about completely mastering a philosophy of human-machine interaction. It's about rigorous prioritization, fighting your instincts to always fly, then navigate, then communicate.
It's discipline.
It's about preserving your mental bandwidth by embracing the dark cockpit. And most importantly, it's knowing exactly when to let the multi-million-dollar machine help you and when to click it off and take over.
It is a masterclass in systems management and psychological discipline. The aircraft is designed to protect the human from their own panic, but the human is rigorously trained to never blindly surrender their ultimate authority to the aircraft.
It's an incredible partnership. And I want to leave you with one final provocative thought to ponder on your own today, building right off the source material we just covered.
I like this one.
We've seen how Airbus brilliantly designed the dark cockpit and the need to see concepts to meticulously protect A320 pilots from sensory overload and preserve their cognitive bandwidth for critical decisions. But look around you.
It's a very noisy world.
Very noisy. As our daily lives become increasingly flooded with push notifications, constant dashboard alerts, vibrating smartwatches, and glowing screens demanding our immediate attention, what would a dark cockpit philosophy look like if you actively applied it to your own smartphone or your workspace today?
Imagine that.
What could you achieve if your environment only lit up when something was truly wrong and otherwise let you focus entirely on flying your own path?
A very powerful concept to take into the day.
We hope you enjoyed this journey into the flight deck as much as we did. Thank you so much for joining us on this deep dive. Keep questioning the systems around you, and we will see you next time.